On guys, let's do this problem right here. The question is asking 2.5 kilogram object on horizontal frictionless surface attached to a spring with spring constant 1000 Newton per meter. Initial displacement is 50 centimeter and initial velocity is 10 meter per second back to equilibrium position. So they are asking for the frequency and initial potential energy, initial kinetic energy, and the amplitude. So let's see how we can find it. So first of all, we have to find the frequency. So we have to use the frequency equation, that is 1 over 2 pi square root of k over m. So they have provided the k right here, and we have the mass, so we can find this frequency. So let's do this. This is going to be 1 over 2 pi square root of k, that is 1000, and divided by 2.5, and if you find the value, this one comes out with this is 400. So if you divide 1000 by 2.5, that's going to be 400, and square root of 400 is going to be 20. So 20 over 2 pi, and that's going to be equal to 10 over 5, and if you calculate, this one comes out to be 3.18 hertz. And that's the answer for the first question. And let's move to the next second one. That's going to be initial potential energy. So potential energy is equal to half kx square, and we have the constant right here, and distance is also provided, that is 50 centimeter. So we can simply substitute that one and find the potential energy. So half time 1000 times the distance, that is 50 centimeter. I have to convert into meter, so if I divide that one by 100, that's going to be 0.5 square, and if I calculate that value, that one comes out to be 125 joule. And let's go to the next one. Next one is asking to find the initial kinetic energy. So to find the initial kinetic energy, I have to use half mv square. So we have the velocity and we have the mass, so we can find the kinetic energy. So this is going to be half time 2.5 multiplied by 10 square, and if I calculate this value, this one comes out to be 125 joule. Then I have to find the amplitude. So to find the amplitude, I have to use conservation of energy equation. Conservation of energy. So maximum energy. So we know that maximum energy is going to be equal to addition of these two, addition of the potential energy and the kinetic energy. Also, this is going to be equal to maximum potential energy. Maximum potential energy. So we know that maximum energy is addition of these two, so that's going to be ui plus ki, and maximum potential energy occurs when the distance is amplitude, because we know that amplitude is going to be the highest distance. This is going to be the highest distance, so that's going to give us the maximum potential energy. So the equation for the maximum potential energy is going to be half k xm square, and from this one we can find the amplitudes, because we already know that potential energy is 125 right here and kinetic energy is 125, so we found that one already. So let's rearrange this equation a little bit. So this is going to be half k xm square is going to be equal to 125 plus 125, and if I rearrange this one, this is going to be xm square is going to be equal to 250 times 2 divided by k, that is 1000, so I directly put it 1000 right here. So this is going to be 500 over 1000, that comes out to be 1 over 2, and this is xm square, so we have to find the xm. So what we can do is simply square root this one and find the answer. So this is going to be 1 over 2 square root, and if I find the value of square root of 1 over 2, that's going to be that gives us 0.707, also that's meter, and that's also equal to 70.7 centimeter, and that's the final answer. I hope you guys like this video. See you next time.